Okay, welcome to the second Detnet session. Thank you for making it back after the break. Since this is an independent session, we're going to remind folks of a few administrative things. First is the note well. This is the same as what we talked about the last session. Please recall that everything you say here is governed by our contribution rules, and anything you say becomes part of our permanent record. If you're not familiar with our note well, hey, it's the end of the week, right? You should know that by this point. But please take a look at the URL. Sorry, I have to remember to eat the mic. Sorry about that. So we are streaming audio and video as well as recording. Please speak your name at the mic when you have a comment. Also join in our joint minute taking. The URL is here. It's also sent to the list, so it can be easy to click on. We are doing Jabber. I'm on Jabber. We do have remote participants, and they should feel free to join the mic line if they have comments. And we do have one remote speaker. The agenda is slightly modified from what we talked about before, specifically that item number 7 we've already covered in the previous session. Also, number 10 is a late addition. So I'm not going to go over the rest of the typical administrative things. We did that in the last session. I think we're just going to jump right in. So I think Andy is next. Oh, no, I'm sorry. Mark is going to present for this topic. So Andy is a co-author and here, but he's not.
Please fill in the blue sheets. Note that we have new blue sheets for this second session.
Okay, hello everyone. My name is Mark Chen. So I'm representing author to present this Detnet controller plan framework. So here's the background of this document. So as we know that to date, the working group mainly focus on the data plan, and they become mature. So I think it's time to consider about the control plan protocol aspect. As we know that the current architecture document has already discussed some controller plan aspects in section 4.4.2. As according to the definition in RFC 17.4/2026, the controller plan actually include control and management plans. So this document try to cover these two parts, and we know that there are some other data plan document already talk about some requirement to the control plan. So the purpose of the draft is very straightforward. We try to compile all Detnet controller plan requirement in this document, and then we can provide an overview of possible control plan solutions based on those requirements. For example, how to define protocol, define extensions in the case of distribute control plan and relevant signaling protocol, or in a fully centralized scenario, or in a hybrid. Hybrid means that there may be some centralized and distributed solution used in a scenario. So this document also discuss other control plan issues that dedicated to Detnet. For example, how to support explicit paths, and how to do resource reservation to support pre-auth functions, and how to and also talk about how to integration with existing protocols. For example, the long SR, MPLS, long SR IP, and also can how to apply this to the SRMPS and SRV6. So this document also describes some aspect about the management plan issue that is unique to Detnet. For example, how to provisioning the pre-off auction and how to do Detnet OEM functions. So this document measure to to document the gaps in the existing control plan solutions. The document this document does not intend to to define some specific solution. The solutions will be documented in dedicated document. For example, if we want to extension the RSVPT protocol, that will be standardized in the TIS working group. So here's the next step about this work. So I think this work has already discussed in last IETF meeting. So based on the current charter, there seems agreement that this work is within the current charter. So the author believe that the current draft is in a good shape and for working group adoption. And once this work adopted, we can continue to improve the document, and also we can start a relevant solution work in relevant working groups.
Can I have a comment on the previous slide? I understand it's the long-term plan and no comments on that. But when you say that that integration with existing control planes, there is SRV6, and we will hear about it soon. But that's a new data plane. So for the rest, actually, we have data plane already, and we first should have maybe a data plane before having a control plane when it comes to SRV6.
Okay, great. I think great. Based on the consensus of the working group too. Yes.
Also following up on it, this is from Jabber, from Bernard Sales. Segment routing is normally only having routing protocol extensions and no signaling protocol at all. Mm-hmm. So that's comment.
Actually, yeah, I think yes. Segment routing has its own protocol, signaling protocol, but in order to, if we want to leverage segment routing to support Detnet, there may be some additional work need to be done. For example,
I think this person is focusing on thinking that controller plane has to be signaled. Mm-hmm. And one of the reason we're using controller plane versus the older term of control plane is that it may be fully centralized, and that you could, for example, do resource management with SR without having to signal it, just from a controller.
Yeah, I think this document does not exclude any potential solutions. It just leave three options here, right? Can distribute, or can fully centralize, or can hybrid. Just discuss some potential solution for the control plan of Detnet.
Yeah, but resource management or resource allocation reservation for segment routing is an unsolved problem. There is no solution, to my knowledge.
Say that again.
So there is no solution, no standard for it.
Right. So right now we do have an issue. This was going to come up later, that we don't have a definition of what traffic engineering for SR means. This is an issue that we've been talking with the spring chair as well as the ADs, and we'll continue to work between now and the next meeting. But I think that's consistent with the point Janar say. Let's not focus on SR to start, and get there as we do work out these other topics. Yeah. Another comment from two comments from Jabber. Bernard Sales says, but centralized is Yang, right? And Andy Malice's response is centralized is not necessarily Yang, although that is an option. And then the response back is, okay, but in general it is.
Yeah, both. I think they're both right.
Yeah. So that was a little bit of an at-mic conversation, and keeping in mind that Andy is one of the co-authors of this.
Yes.
All right.
Yeah, I think. Yeah, yeah.
Okay, so we've previously looked at this document and tried to get a feel for the room. I'll do it again. How many have, actually, I'm going to ask the other question first. How many people think that we should be working on this topic in the working group? So controller plane work for Detnet. Okay, that's a reasonable number. How many think we should not be working on this? And keeping in mind, this is a gap analysis. This is not a solution document. So I had someone who looked like they were going to come to the mic, but when I made that caveat, I think they sat back down. Right. So I think the objection there would be is if we start talking about solutions, there are other working groups that own the solution space, and we shouldn't jump on their activity, and that's absolutely correct. So we've said that there was a good number who thinks we should be working on this. There were no objections. How many think that this is a reasonable foundation for our work in this area? In other words, we should adopt. How many think we should adopt this document as a starting point? That's much less who then think that we should work in this area. That's a little bit of a surprising result. Maybe I phrased it in a way, but no matter what.
Yeah.
How many have read the document? It's all right. That was a good question because it's about the same number who raised their hand.
Yes.
So this is something we're going to confirm, number one, that for our AD, that this is something that we can be working on. Assuming that the AD says that it's okay, we will be taking this to the list.
Okay, thank you. I think please read the draft and comments, right? Okay. Thank you.
Great. Thank you very much. Next up, we have one of two SRv6 talks. It's really weird that this says Flex-E here. Be careful when you have a presentation and have a title. When you steal it from something else, it shows up.
They reused the previous This is Xue Song, and I will present our work about SRv6 for Detnet. Here is actually why Detnet from the first place.
Oh, excuse me. Unfortunately, I was talking at the mic. Andy is saying hand up, hand up, hand up repeatedly. It's the danger of being chairing and also being jabber scribe. Andy, did you want to make a comment, or were you just hands up agreeing? Oh, he was just agreeing. Sorry about that. All right, thank you.
Why we need Detnet from first place? There are some new applications and bring some new requirements for network. So perhaps we need some new technologies rather than the traditional ones. So we need Detnet. And I think people in the room may be very familiar with these three features of Detnet: the resource allocation to avoid congestion, and the service protection to provide redundant transport to avoid the failure of the flow, and also explicit routine. So this work, we try to implement Detnet in an SRv6 domain. So why SRv6? First, SRv6 is source routing, and SRv6 could steer the packet flow through the network according to an explicit path with allocated resources. And second, network programming. SRv6 can support the the functions that will be needed in Detnet, and also metadata. SRv6 could carry the information that will be needed in Detnet, for example, the flow identification and sequence number. So why not? Here is the architecture for SRv6 for Detnet service protection, because there are 3 features in Detnet, and in this stage we just cover the service protection first. And the first is the data plan. Basically, the packet will go through the ingress node, and in the ingress node, it will be inserted the SRv6 policy that will steer the packet from the ingress to the relay node. And also the flow identification and sequence number will also be carried in the SRH. And in the relay node 1, packet replication happens. And after the replication, the payload and the IPv6 header with the SRH binding to different SRv6 policies, which steer the packets through different paths. And in the elimination node, the redundant packet will be eliminated, and the survived one will transmit it through relay node 2, go to the egress node. And in the control plan, we're considering that the first, there should be a path computation request from the edge node to the controller to see that the Detnet flow want a service protection path in order to have ultra reliability. And after the computation, the controller will send a path to the edge node and also the replication and elimination nodes. So Stuart, you want I finish it first, or you?
No, carry on. Can I have a question to ask?
Yes, and after the controller configure the edge node, it should also configure the relay node, and the replication elimination node should be configured to identify the Detnet flows by flow identifications. After replication or elimination, the explicit path to the next relay should also be required through some control plan extensions. Any comment?
So I'm trying to. You're clearly describing, Stuart. You're clearly describing doing pre-off in this, but pre-off requires sequence numbers. How do the sequence numbers get carried?
It will be described in the next slide.
Okay.
Yes.
Dave Allen Erickson. The statement binds a new SRv6 policy to the survival packet. Does this involve inserting information?
You mean searching for what kind of information? Actually, this is insert. Yes, it's basically a binding SID. Actually, after the elimination,
it's a binding SID that was not part of the information inserted at the packet R1, right?
You mean the information of flow identification and the resource number, the sequence number?
Well, there's the part where you do the sequence. You proceed to replicate it and put the sequence number in. I understand that's done with a tunnel, because
yes, I think so.
Because you're discussing decapsulating the outer IPv6 header.
Yes.
And I'm assuming that's not manipulating the segment routed list, but the insertion or the binding a new SRv6 policy to me sounds like you're inserting new information into the IPv6 packet, into the segment list.
Actually, there is an example about how to do this. I think this will answer your question perfectly. Yeah, maybe you can give more comments after that.
I will wait.
Thank you. And here is the what do we need when we do SRv6 based Detnet. First, we need a method to identify the Detnet payload type, and also a suitable explicit routine to deliver the Detnet flow, which will be supported by the segment list in SRH. And also, we should have a method of indicating the packet processing, such as the functions required in the service protection, for example, packet replication, ordering, and elimination. Also, we need a method of identifying the Detnet flow and carrying the Detnet sequence number. Actually, carrying queuing and forwarding indication will also be considered, but it is not in the current version of the draft. Here, we bring some options to do this. First, we can to carry the flow identification and the sequence number. The first option is we carry this in the SRH TLV. And the second option is to arguments in the seed for relay node. And the third one is a Detnet seeding segment list. And option 4 is Detnet SRH insert inside the SRH. Because the limited time, I just will introduce we think the most reasonable one, which is the option 1. We carry the flow identification and sequence flow identification and sequence number in the optional TLV, and we designed how to encoding them in the SRH. And here is that we design new functions for Detnet, which is replication and elimination. You see that is basically an extension of the current binding seed. It means that after replication, it will binding new segment list to the packet. And also this one is after the elimination, it will binding a new segment list to the packet. And here is the example how to do this. Basically, in the IPv6 header, there is the source address and the destination address. In this picture, it shows as the end station 1 and end station 2. And in the ingress node, we will insert an SRH that carries that its source address is ingress node, and the destination address is transit 1. And in the SRH, the segment list shows the relay node 1 and the transit node 1. And in transit node 1, the destination address in the outer IPv6 header will change to relay node 1. And in relay node 1, we see that after the packet replication, there will be new alter IPv6 header for 2 replicated packets, and each SRH header in the alter IPv6 header will indicate the packets go through different paths, and one of them will go through transit node 2, and one of them will go through transit node 3. And in the relay node 2, the packet elimination happens, and after the elimination, the alter IPv6 header will change, and we will bind another alter IPv6 header with a new SRH, indicate the packet go through transit node 4, and in the egress node, the alter IPv6 header will be decapsulated, and the packet will go to the end station 2 finally. So that is the simple example of how to do this. I think this maybe can answer the question of the previous comment. So
thanks, Charles Eckert. I think it would be good for understanding by people to have a comparison between, just native IPv6 data plane, where we would also need on a per hop basis the appropriate shaper for the latency control that we need in Detnet, and then compare that native v6 data plane with the SRv6 solution, and then explain what the benefits would be, right? Because I think that is hard to vet just from looking at this solution. Obviously, the interesting part is the transit, not the stuff on the edge with the duplication, deduplication. I think that part would be certainly the same.
Balázs Varga Eriksson. So my question would be for clarification first. So is it a new data plane?
Yes.
But it is focusing only to a single function, to the pre-off function that you have described so far. And for the data plane, we need both the Detnet service sublayer and also the Detnet forwarding sublayer.
Yes. Actually, can I respond now? Or
Yep.
Yeah. Actually, in the draft, I described this part because in the previous design, in the MPIS data plan solution, there is we can find the service sublayer and forwarding sublayer obviously because it's label stack, right? But in SRv6, it cannot be separate very obviously which part is forwarding sublayer and which part is service sublayer because the metadata that is needed by the service sublayer is carried inside the SRH. So although there is no sublayer seams in the data encapsulation, but inside the process, the device process, it will be a service sublayer and forwarding sublayer, and each sublayer will do their own job. But they will find the corresponding information inside the SRH from different part. But it is not seems like the MPS data plan.
Yeah, but I think this is what is my major problem here, that if we are looking here to the transport node, and I think this is what previous commenter also commented, is that in the transport nodes or transit nodes, you need Detnet forwarding sublayer, how to recognize the flows if it is within your SRv6 header, which by definition should not be touched by the transit nodes.
Actually, if more functions will be needed for the transit node, I think the transit node should have a seed to indicate that because it needs some special processing or functions. That is reasonable. But in this case, I have already said that in this case, the only service protection is included because replication and elimination is the main focus in the current draft. And perhaps after this part of work is accepted or people think that is reasonable, and we can go further to the other functions about maybe the transit node, what should transit node should do.
Yeah, but this definition seems to prohibit to do the
not really
forwarding sublayer
not
functions.
Really. Actually, I think I have a picture for that afterwards. In this picture, I show that for service protection.
So is it part of the document? Or
not really.
Not
but
yet. Okay.
Yes, okay. But it's a whole picture. We have considered this question actually.
Okay.
So you started to explain. Can you then provide the answer?
Inside the draft?
No,
just
you will just explain the picture.
Okay, I will. In this picture, it shows that service protection need the metadata of flow identification and sequence number, right? So we put in the option 1, we put these two information into the optional TLV in SRH, and in service protection, we also provide some special functions to do this, including replication, elimination, and ordering. So we will extend the current functions of SRv6 programming. We need new functions for that. We have already discussed this before. And also in the left, we see that we also need some resource allocation. In this resource allocation, maybe we need new functions for scheduling or resource reservation. If so, we will also do the extensions to the functions. And if there is new metadata needed, then maybe we will add more data into the seed as an arguments or inside function that will be a lot of implementations. Yes, that is my answer.
Yeah, but that is my question, and that was my issue, that in the SRv6 fields, this is something that is not considered by the transit nodes. You are not looking to the SRv6 header fields in a transit node. You will just check it at the next destination.
This transit node is not the same concept in the SRv6. This transit node is just Detnet transit node. That transit node means that it doesn't handle the problem of replication and elimination. It is not exactly the transit node in SRv6.
Okay, so then you are defining a new type of SRv6 capabilities of nodes.
Yes, actually, that is what we are doing. We try to define the Detnet corresponding functions in SRv6 to implement Detnet.
Okay, so what about compatibility with the existing SRv6 definitions?
It's an extension to it, so maybe that is the reason why Lou said that we should put it in Spring first to see what SRv6 people think about this.
Okay, so because I think if we intend to consider it as a data plane for Detnet, then we should see all the aspects that both sublayers, the service sublayer and the forwarding sublayer, the functions we have defined so far, they are possible to do with this data plane.
And that is very reasonable, and because you are, you have been working on the user plan, the data plan definition for a long time. So I think your comments will be very valuable for us to move this forward. What should be done? What should be considered more? Thank you.
Okay.
A clarifying question. Do you mind going back to that slide, the first version? Can you highlight where? Whoops.
This one?
Yeah. Thanks. Can you highlight where in this picture you see that there are new SR functions needed?
In the relay node and the elimination node. In the replication node and the elimination node. And in this picture, that is the relay node 1, R1, and relay node 2, R2. The R1 will do the replication, and that is a new function. That function is an extension of the current binding function of the SRv6 network programming. And also in the R2, elimination will be done. So there is a new function for elimination. And after the elimination, there will a new SRH binding into the packet.
Okay, thank you.
Right. So, so David Allen again. My generalized question is, for example, does R1 or R2 modify the segment list?
Modify? No. Because they just change the alter IPv6 header.
So you add an encapsulation with its own segment list?
Yes, because that is, yes, I think you said it right.
Right. So at R2, you remove the outer IPv6 header entirely.
Yes.
Then where does okay, I'm just trying to figure out how that. So at the in router and at the egress. So the in router insert is there two layers of tunneling here?
Actually, there is only one layer because from the beginning to the end, there is only one alter IPv6 header. In the relay node and the two relay nodes, which do the replication and elimination, we change the alter IPv6 header.
Okay.
Yes.
It's just that at the ingress node, getting to the egress doesn't appear to be there.
So there is no IPv6 SRH to indicate the packet from the ingress to the egress. In the first part, it just steer the packet from the ingress to R1. That is the first part of the pass, and in the second part, it steer the packet from the R1 to R2.
Right, and that's where you push an additional header because you're going to have two separate segment lists, and then at R2 you pop it.
Yes.
Then where does the information to get to the egress exist in all of this?
Actually, here there are some description in the function design. We reuse some information bring from the previous SRH header, which in this picture, in this slide, we can show that we bring the sequence number and flow identification in the optional TLV in the first SRH, right? And after the replication, we will get this part of information and put that into a new SRH in the new SRH optional TLVs to make the information of the flow transit from the first part of the path to second parts of the path.
Okay, I have to admit I'm not understanding this, but I think that's my problem. I will have to review this and take it offline.
Thank you. Please read the draft and comment on the mailing list.
So we've done a good job of filling up time. So while we were ahead, we're now right on time. So I'd like to ask the folks in line to try to keep it brief. Mm-hmm. And I'll also give a preview of what the chairs are going to say on this is any new any new SRv6 function like this split merge, we have to take to the working group.
Yes, it's
the
reasonable.
Working group.
Yes, it's reasonable.
And talk to them about it. So we're going to have to do that. So that's just a heads up that's coming. And now. Yes.
So, Secretary again, I mean, my understanding is that there is an SR architecture, right? And would really be good to say that how are we doing Detnet in SR with the ability to support both SRS, MPLS, and SRv6. The gaps for both of them may be different in terms of forwarding plane features, but the architecture should and could be the same, right? So I kind of hate the idea of saying, oh, today we think SRv6 is hip and leave, the SR MPLS solution behind. And then, I don't know, next year, maybe there is more sales being made with SR MPLS and everything shifts back. So I'd like, if we're saying SR, let's start with SR and then go down into, the gaps for both solutions.
Thank you, Todis, for a comment brief response. I haven't considered this problem from the view of the sales. Actually, it is said in the previous data plan solutions draft that if we use SR MPS, it is supported naturally by the current MPS data plan solution. So there is no more job in SR MPS.
I'm not sure if that's actually true for the hop by hop QS.
So comment that to the other orders is not my fault.
So please, could you clarify, because I didn't properly understand.
We can't hear you.
Stuart,
No, just
sorry. Is there only ever one segment routing header on the front of this packet?
Yes.
That gets completely removed and replaced by another one when you go through any stage of the pre-off?
Yes, in the current design, that is true.
Sorry, when you split? Well, actually, you don't necessarily divide by two. The architecture allows arbitrary splits and arbitrary merges. And I was just trying to understand, making sure that you weren't making an assumption of one single replication going on a path. So if you go back to your figure,
yes,
that's that one there. Mm-hmm. So first off, R1 in the general architecture is allowed to be replicated, have multiple replications there. And then T3 could be R3. So I'm just trying to understand whether your design will cope with the generality or whether it's assuming a very simple two-way splits and merges.
Actually, I think it is a very valuable comment, and we consider this problem from the beginning. We designed it this way because if we replicate it again in a replicate path, it will make the things more complex, because we allow this case. This is just the simplest one. If we do the replication again in one of the paths, and we merge in that path, it will make there will be header and header and header.
Right.
So that will make the case really complex. So we designed this way. But if you think there are other reasonable design, I think it's welcome.
Well, what I think we need to, all right, what we need to do in the next version, what you need to do in the next version, I think, is to take some of the arbitrary replication pre-off function designs that we have in the framework document and demonstrate how you would solve those, because this is easy to solve and we just need to make sure we can solve the general case or put the limitations in.
Please contribute. Thank you. Thank you.
Ulla Jorgo Eriksson. In the document, in the pre-auth section, in section 4.3, you are speaking about point to multi-point to point paths. And just thinking about that, we intend to work also on some controller pin stuff. So I don't understand that term. So please clarify what does it mean, because I think as Stuart also refers to that you can do any number of replication elimination during the path. So what does it mean that point to multi-point to point?
Maybe this word is a little confusing. I can explain it or remove it, but in my understanding, it just means that it's just it is not P to MP. It after the replication, the elimination exists. That is what I mean from the first place. But if it makes you a little confusing, we can talk about more how to describe this case.
I think that is very confusing, especially because you are using practically point to point.
I think we really have to take it to the list. We're definitely way over at this point. We certainly have some procedural stuff we have to work out here.
Yes.
We'll continue to work with the SR, the spring chairs. Forward, back. No. Forward, back.
Good afternoon, everyone. My name is David Dai from Fiberhome CICT. And the draft is Detnet TSN, that is the IEEE 8.2.1 TSN over SRv6. Let's take a look at the structure of the TSN over Detnet. And it is similar to the TSN over SR MPLS. And the left part and the right part is all the TSN network. And the mid part is the SRv6 domain. And the CE1 and will send the traffic based on TSN to PE1. And the PE1 as an edge node of SRv6, and we'll perform the functions of mapping and verification and elimination, and send it to the PE2. And after PE2, then the traffic of TSN will be recovered to send it to CE2. That's the basic structure of TSN over Detnet. Now let's take a look at the solution of the encapsulation structure of TSN over SRv6. We have got several options for encapsulation of TSN over SRv6. The first one is just a packet in packet. And the second one is insert the data into the SRv6 packet together with some control informations. And the third one is just this figure. Because we think about the SRH, the overhead of SRH is a little larger. So I think we should, in order to save the overhead, we should just use the payload of the TSN and insert the payload into the SRH, just follow the SRH. And to the SRv6, where edge node must support the following TSN component. The first one is the recognition the flows, including the stream identifications. And the second for FRER used inside the TSN domain. And the third one is for FRER when the node is a TSN replication or elimination parent. And this is the encapsulation structure for SRH for TSN. We have just indicate a minor change for the SID, and with the backward compatibility with the SRH defined in another draft. Next page will give a detailed introduction for the SID. We have defined SID, Detnet SID similar like this. That's a TLV. And with a 64-bit long flow identification and sequence number. And the other bits are reserved for the future functions. And we also defined two new and SRv6 programming functions. That's the NB replication, Detnet SID, and B elimination for the pancake elimination function. And this is just the description in this draft. And in the future, maybe we need to discuss and elaborate the two functions. And at the moment, I would like to take an example of the NB replication for the Detnet SID. And just in the edge node, we will, based on the original packet and generated to duplicated packet based on the different IPv6 SRH. That's the IPv6 SRH1 and IPv6 SRH2. And then we will send the duplicated packet and the original packet to the different paths. Now, let's give a summary for the data plan considerations. Then the two aspects. The first one is the Detnet packet replication and elimination order functions. And the second is the edge node processing. And to the management and control information summary, we included the four aspects of information here. That's the first one is the TSN string identification and the TSN R-tank information. And the second is IPv6 source address. And thirdly is the IPv6 destination address. And the fourth is the IPv6 traffic class. And to the next step. And furthermore, we will solicit the comment for this draft. And second, we want to elaborate the draft. And second, certainly, we want to advance and improve the implementation for these suggestions. That's all about this draft. Thank you. Any comment?
Actually, I have to ask, what is the difference between this work and our work?
You mean the draft you have give the introduction right now, right?
Yes, because that draft is published about 1 year ago, and the contents of the draft is very, very similar of this one. If you haven't read it, I recommend you read it this first. And because it is too similar with each other, I have to say, I prefer you put this part of work as an contribution or a comment on the mailing list, because I cannot see a lot of more work in this draft compared to our previous one.
Yes, we have searched for the website for the similar draft. We have got 5 similar drafts related to this one. But from my side, those 5 drafts is different from this one. And your draft is focused on the Detnet over SRv6, right? And this one is focused on TSN over SRv6.
Actually, I think there are some misunderstanding about the what we want to do when we say about SRv6 over TSN. Maybe.
So can I make a point on this?
Yes, please.
Or related one. So
please.
These are individual contributions, not adopted by a working group. Maybe one way forward could be that the two teams, contributor teams, got together and work together.
Yes, this is very welcome. But my point is, after we have done the work, you change it a little and publish a new draft. I think that is not a very welcome method to do the contribution in IETF. I think so.
I think I should repeat, neither of them are adopted by the working group, neither this working group or Spring. We keep saying we don't know where it goes. So these are so far individual contributions, not working.
So I thought that maybe you and me and my colleague will change the draft in the website. If they are identical, we will withdraw it. If they are different, then we'll continue our research independently. And that's my suggestion. And from my side, your draft is basically is different from this one.
What can I say? Thank you.
Yeah, generally, if you have some comments on an existing document, it's good just to send the comments to the list.
So I will
work together
with her through the email. Okay.
Perfect. Perfect. Thank you. Yeah, apparently this is an ISIS group document.
Yeah, this has the same problem. In this tab, it says ISIS. And since we are talking about it, the very last slide says beer resilience.
We're going to move on to the next presentation. So thank you.
Good afternoon. I'm Chen Xiong from ZT. My presentation today is the Detnet QoS. The draft has been presented in IETF 103, and we got little feedback. So this meeting, we hope to get more feedback. Our draft mainly applied the existing queues work under Detnet. Let's do the quick recap of the IETF queues. The IETF queues model has been proposed and adopted by the RTGWG working group. It mainly includes the policy, classifier, action, and target. And it mainly uses the differentiated surface. It's diffserv for short. Under the diffserv architecture is defined in RFC 2475, and MPL's diffserv is also defined, and in the RFC 3270. So there is much work has been done and stable for the IETF queues. So we summarized the Detnet queues requirements in RFC 8655. So they are as the follow shown. Detnet and long Detnet flows could coexist with existing class of surface, and the Detnet flows must be differentiated from low Detnet traffic. Non-Detnet traffic cannot disrupt the Detnet flows, and Detnet flows can be shaped and scheduled. The aggregation of Detnet flows must be supported, and more others can be provided. So the Detnet QoS draft, we mainly apply differentiated surface, the diffserv and the queues model in Detnet, and define a Detnet diffserv mechanism, including Detnet IP and MPL's encapsulation, maybe as RV6 encapsulation later. And we also define a young late data model for Detnet diffserv queues, including Detnet queues tree structure and the Detnet queues module. So this is the Detnet diffserv model. The diffserv model includes the classifiers, DSCP, traffic conditioners, PHB, and Queen. So we extend the diffserv model for Detnet. We define Detnet classifiers. We may use the behavioral aggregate, the BA classifier, or the multi-field MF classifier. which is defined before, we maybe use the BA and MF classifiers in Detnet. We also add a new Detnet classifier. It named Detnet flow. It is DF for short. It may be used as label in Detnet MPLS encapsulation, and maybe used flow identification in SRv6 encapsulation, maybe in later. So we will use this field to classify the Detnet and the low Detnet flow. Second, we define the Detnet DSCP. It includes Detnet IP DSCP and Detnet MPLS DSCP. The exact value we haven't defined. We want to discuss with others in the mailing list and define a value. Third, we define Detnet traffic conditioners, including meter, marker, shaper, dropper, and we add a new action, the scheduler. We will define a Detnet profiler to do the meter of action and to see if the Detnet flow is meet the Detnet provider's requirement. So then we define a Detnet per hop behavior, the PHB. We define a Detnet PHB and define the DN service class. Then the Detnet queuing, as we well known, so far we provide the time schedule queuing, and this is specified in other drafts. So this is the DeepSurf model for Detnet. Then based on...
So at the last time you presented this, there was a question of what is a Detnet DSCP? And it sounds to me, as I hear it and as I read it, is you're defining a new PHB for Detnet.
Yeah.
In Detnet, we have per flow resources. And it's a little hard to understand what a Detnet PHB is relative to per flow resources. Could you talk about how those two things relate? This was the same question from 103, and I don't think it was been addressed. Or from the last time it was presented. I can't remember what meeting it was that it was presented. But
yeah, as I understand, as in my opinion, per flow, the schedule, the queuing mechanism, the Lomafin has provided the mechanisms, including the per flow and the per class. So I think we use the DeepSurf model. We mainly use the per class queuing mechanism. Belong to the
so
per
the
class.
only allocation the only assurances you can provide to when using this is a class-based allocation or class-based. Okay. I'm not sure how that fits in with the whole Detnet architecture.
But the queen's mechanism has not been conferred. We will use the per class or per flow. It has not been conferred.
Maybe I still don't understand how this relates to the rest of the Detnet architecture. And maybe I'm the only one who has that issue, but I don't find it clear. So maybe if it's just me, I'll work offline and try to understand how this works.
Okay. So the work we has much work to perfect it. So the DSCP and the PHB, we need much work to fill it and perfect it. But so I welcome people to join us and give our suggestions.
So it's not clear to me either, but anyway.
Yeah, I think that's the challenge is to think about how to communicate how this fits into the rest of the architecture. Because in order for it to move forward, we'll have to be clear there. Let's see what the working group thinks. How many people have read this work? Very few. How many people would like to hear more about it in the future, maybe with some clarifications of how it ties together with the rest of the Detnet architecture? Is anyone interested in hearing more about this topic? That's not good. There's no one who seems interested in this work. I think you have to do a much better job of communicating how it relates to the rest of the working group activity. Try doing that on the list, but you maybe take a step back and come at it a different way, because people aren't understanding. I think the way I read it is people aren't understanding how this relates to the working group.
Okay, thank you.
All right, thank you, appreciate it. Last up, and we're almost out of time, or this will be very quick.
Yeah, so while Louis is bringing it up, the idea was that we would have time to talk about it, and it was a year ago when we had the workshop, and we are proposing another one. So just a quick update, I'm speaking as an individual, as usual, and this is grouping of TSN standards and projects in 3 categories: base technology, configuration solutions, and profiles. A timeline is given compared to the last IETF in Bangkok, where we discussed this topic. Just to highlight that if you are puzzled on the TSN technology, that we have so many standards and projects, you are not the only one. That's why we have profiles dedicated for particular verticals to select tools out of the toolkit and specify their use. The color code here is that the darker a shade is more progressed the work, the lighter is less progressed. In the profiles, the ongoing ones are the IEC IEEE 60802 joint project for the industrial automation vertical. We have an extension to the front hole profile CMDE, and there are new ones, automotive, in-vehicle, and one for service provider networks. How to use TSN for these. This is again, there are some highlights compared to the previous Bangkok presentation. I would like to highlight 2 items here. The really good news out of last week is that our time synchronization standard, the 802.1 AS Generalized Precision Time Protocol profile of the 1588 PTP has been approved by the IEEE 802 itself and sent to IEEE Standard Association Revision Committee approval, hopefully early next year. So we are practically speaking done with the long-awaited new time sync revision. And there are some new work items here in the resource configuration part of the TSN pillars. I would like to highlight here that work is ongoing to specify new reservation protocols. The BRACE protocol being the so-called linked local registration protocol. On its own, it's not really useful, but we need an application on top. And the ongoing work is the resource allocation protocol for that. This is a new project compared to 1 year ago. The two together will provide the new resource allocation, and this work has been started to meet the industrial automation needs. Based on hallway discussions with the key contributors, they consider it applicable for Detnet as well, and I've been encouraging them to contribute to Detnet. So a heads up, these contributions may show up here. Another new project is the LLDP version 2, which was largely triggered by the LSVR work going on in IETF. And to summarize, IEEE 802 is on individual contributions, individual participation, just like IETF. You are welcome to contribute and participate.
Any last questions? All right, thank you very much. Appreciate you contributing to our work. We've produced a good set of documents that we will see in that are post last call, and hope to see RFC soon. And see you in Vancouver. Thank you.
Can you do me a feed? Sure.
You know what? I don't.
That's okay. I have your email. Yes, absolutely.